هلو صبايا كيفكن؟ نحن اتفقنا انه نقعد سوا ونعمل بركي وحدة solving session for charging and discharging of a capacitor. نقيت a problem that is regular ما فيه حركات. نقيت دورة الأولى تبع سنة 2011 علوم الحياة عادي. Probably after this session فينا نعمل we can solve the problem given by Helen, okay, اللي فيه LN and probably نعمل دورة فيها LN, okay. وإذا الوضع حسيت أنه عم بفيدكم probably أعطيكم many solving sessions, okay. So حبيت أترك هيدا السلايد فاضي. Probably I can use it as a quick reminder. So a quick review what you need to remember. You need to remember أول شيء أنه the capacitor في عندكم the charging process and the discharging process. Excuse me. How do I know the difference between the charging process and the discharging process? Every time you have a generator, obviously the capacitor is charging itself. When you don't have a generator, the capacitor will be discharging itself. In any case, I is equal to dq over dt in case you are in the charging process, and in case you are in the discharging process, you can replace dq over dt by negative dq over dt because the current will have an opposite direction, okay? Probably I need to remind you quickly that the u function and the q function as a function of time and the u function and the q function as a function of time. So probably remind you that Q is equal to C times U across the capacitor. So they're both proportional, Q and U. For the charging process, you will end up with an exponential increase. For the discharging process, it's an exponential decrease. I don't want you to hear exponential and to freak out. You need to understand it's an increase that happens fast at the beginning and slow at the end, like you discharging the battery of your phone. We call it exponential increase, exponential decrease because it's fast at the beginning and slow at the end. It has a tail. For the current, however, it's always a decrease because if you're charging the capacitor, it's gonna get full, and the current is gonna stop at the end. And while you discharge the capacitor, it's gonna get empty, and it's gonna get zero at the end. So in both cases, the current is zero. So you have a decrease to zero for the charging and a decrease to zero for the discharge. The only difference is that this decrease is in the positive quadrant and this decrease is in the negative quadrant, because while you're charging the capacitor, the current is in one direction. When you discharge, the current is in the opposite direction. And that's why I use plus for the charging and minus for the discharge to discuss the current. All right. So in all cases, it's exponential. Every time, so this is the charging process. So this is charging and this is discharging. Okay, what else? What else you need to remember? Every time you need to write the differential equation, you need to start with U generator is equal to U capacitor plus U resistor, okay? U resistor could be replaced by Ri, okay? U capacitor could stay as U capacitor, or could it be U is Q over C. You can replace it by Q over C. Also, you can replace Q by, or you can replace I by dQ over dt. So if you want Q on both sides, this would be Q and this would be dQ over dt, okay? This should be replaced by E, which is the potential across the EMF of the battery, or zero in case you don't have a battery, okay? So I don't want you to worry about replacing I by positive, negative dQ over dt. You can simply put it as absolute value as long as you follow this equation. But keep in mind, if they ask you about I alone, and you'll see it in this problem, don't forget during the discharge, it's a negative value because the dq is negative and you want your current to be positive. That's why you add a minus sign. I'm gonna get back to this one in a moment, okay? In case you haven't, you would know you have a charging if you have a generator, and you know you have a discharge if you don't have a generator. How do you write the equation for the charge? If you have an exponential increase, let me change the color of my pen. Every time you have an exponential increase, it has a shape. The shape of it would be, let's say, u equals something constant, parenthesis, 1 minus exponential minus t over tau. Okay? This is in case you have any increase. A, what is A? To be able to find A is the maximum value. So if we're talking about U, the maximum is big E. If we're talking about the current, the maximum is big I, all right? Now, if you have a certain decrease, how does the function look like? It's gonna be U equals the same thing, but without the parentheses, just exponential minus t over tau. When I was a kid, I had difficulty to remember which one is the increase, which one is the decrease. So I tried to say, well, Jesse, you know, you have two minuses, so that's an increase. When you have only one minus, that's a decrease. Let me add a bit something related to tau. What is tau again? All right. So tau is equal to RC. This is the best way to find tau. And it's also important to remember that this is in seconds, this is on ohms, and this is in farad. Okay. You may be asked to prove why tau is in seconds. And probably I'm going to get to this later, but this is covered in our chapter. You know, go back to the chapter and it's covered somewhere. Otherwise, I can give you a session for that, and please feel free to ask me anything you want. To be able to find tau also, you can take any increasing function, okay, because increasing functions are easy to handle. This is the maximum. Let's say it's E for the voltage. You take 63% of E, you go to the curve, you go down, and you find tau. So this is how you can find tau. Don't forget tau is on the x-axis. Also, what you can do, this is another increasing curve. And so this is the increasing curve, and this is the maximum it can reach. You can draw the, what do you call it, tangent at time 0. And the tangent is gonna hit this point, and this distance is tau. You can also find the distance on the lower axis. It doesn't matter as long as it's a horizontal distance. Keep in mind, for any time equal to 5 taus or 5 RC, the charging process is gonna end approximately like 99.99%. Now let's see what the question is about. So this is a problem. I'm gonna zoom in a moment. You would see that you have a switch, 1, 2, and the switch at 1 will give you charging because you have a battery. When the switch is at 2, it's gonna give you discharge because you have no battery. At 0, neither of the charging or the discharge is happening. Also, you notice that the problem is divided into 3 parts: big A charging, big B discharge. You also see charging is very short, discharge is longer, so most of the problem is here, and the title is discharging, so it makes sense. And C is basically a conclusion, so it makes so much sense. I'm not gonna read it because I think it makes sense to us. They said the capacitor is initially uncharged and the switch is on position 0. To which position, 1 or 2, must we turn the switch K in order to charge the capacitor? The charge. Obviously, it's gonna be 1, okay? Now, they want to say that the U of the capacitor, has this shape, which is an exponential increase or decrease. Let's think about it. I have a minus and another minus, so it's an increase. And I know it's a charging process, so it's obviously an increase. Deduce the value of UC in terms of E at the end of the charging process. At the end of the charging process, we know that the time is 5 tau. So if you simply replace this one, okay, I think I need a smaller pen. Let me change this to smaller pen. So in case I want to replace small t with 5 taus, because at the end of the charging process, I have 5 RC. RC and RC will cancel out. You will end up with E into 1 minus E minus 5, because it's 5 RC over RC. By the way, you can simply keep it like that, or you can calculate 1 minus e minus to the 5. When you see exponential, remember, this is a physics exam, and you're not supposed to know a lot about the function exponential. It's a simple function on your calculator. Just learn how to use it. Click E on the calculator to the power minus 5, and it's going to be a value, you know? If you want to look at the solution, they say position 1. You can check the key later, I mean the grades. At the end of the charging, they say t is equal to infinite. When t is equal to infinite, okay, so probably here you need to you know some stuff. E to the power 0 is like any number to the power 0, so it's going to be 1. E to the power infinity is like any number to the power infinity, so it's going to be infinity. E to the power minus infinity, it's like 1 over e to the infinity. So 1 over infinity is practically 0, okay? You can use idea 1, 2, and 3 whenever you need to do exponential. So they said that at the end of the charging, t is infinite. 5RC, or they said, or you can say t is 5RC. Both are okay because as you can see, it gives you the same answer, okay? 5RC is a lot, so it's like infinity, if you want to call it. And by the way, they did the calculation for e to the minus 5. That's it for part A. You see how small part A is? Now part B, let me duplicate this one to be able to remove the solution. And let me remove it by removing my pen, and let's see what they want in this case. All right, the discharge, now the charging is completed. To which position? You will definitely, probably we can take the circuit diagram with us. Okay, so we can use it. I'm on this slide. I'm gonna insert picture, the last screenshot we did, this I suppose. Yes, all right. So which position? Obviously position 2 for the discharge. And then they say at time 0, the starting of the discharging, draw the circuit of discharging and indicate on it the redirection of the current. All right, so now, you know, when the position was on 1, the current was in this direction, okay? Right? That was during the charging, which made my capacitor to have a positive side and a negative side. Positive on the positive of the battery and minus on the minus of the battery. Now, you know, remember, it charges itself like this. It discharges in the opposite direction. So the discharge is going to happen like this. So you're supposed to show the green arrows for the current. So this is current. And then they say, explain why, or pick, is it minus dq over dt or positive dq over dt? You say it has to be negative because the current is opposite to the original one. Okay, then they say show that the differential equation has the form. Remember, you say U generator is equal to U resistor plus U capacitor. They gave you the answer, by the way, you're so lucky. So this is Ri, and this is Q over C, right? And this is 0, and you can add a plus in here. Now replace I by dq over dt. Okay, how close are we to this one? Okay, let me check a bit. Let me remove those. Di over dt. What's di over dt? Okay, let me do it again. Let me see. They want me to keep I and to change Q. Let me try, okay? So we know we're sure about the 0 on the left. So I'm gonna keep this to be Ri. By the way, if you look previously, I exchanged UR and UC. So I'm gonna keep this to be Ri. And I'm gonna replace this by Q over C. Okay? And if I do the derivative on both sides, so if I do the derivative for the whole thing, I'm gonna get 0 equal to R di over dt. I think I'm very close to the answer, plus 1 over C dq over dt. So I did derivative with respect to time everywhere. dq over dt is I. I think I got it. Okay. And the space lacks me a bit. So this is I. Probably I can show you that this is I. And you already have di over dt, which needed. And then you multiply everything by c to remove 1 over c, and you get to this one. All right. We never did differential equation in I. We usually do it in q or in u. But how can I get di over dt? The only way was to do derivative everywhere. You're lucky you have the answer. Okay, verify that this is the solution. To be able to verify that this is the solution, you simply replace I by this guy. So put I in here and I again in here. Now you should know how to do the derivative for a certain exponential. Probably I can remind you, and I know you hate this part, and we can practice if you want. E to the power u, if you want to do the derivative of this one, is u prime e to the u. Okay, so u prime is the derivative of what you have in the power. E to the u, you just write it again as is. Trace the shape of the curve representing the variation of I. It's gonna be decreasing function. You see the decreasing function. Okay. Give in terms of R and C the duration at the end of which the capacitor is practically completely discharged. We know it's 5 RC, and we see how we're gonna prove it. Now let me check the answers. And yeah, they said it has to be on position 2. We drew the circuit with the current. We said that the current should be the positive, and since Q is decreasing, dQ over dt is negative, so we add a minus. Okay, they explain because of the discharge. And here they show the differential equation. Don't follow their method. I'd rather follow UG is UR plus UC. Replace, then do that. They did exactly the same, but they started with the fact that I is dq over dt, and they continued. So two methods, but this method we never tackled. We always start from this one. Why I like this method? I like this method because I can use it for the charging and for the discharge. That's why I stick to it, and it's going to give you the same answer eventually. Now they did the I and the di over dt, and they replaced in the differential equation, and they prove that eventually you're going to get 0. Okay, and this means it's verified. This is an exponential decrease, and they simply said that the time for the discharge is 5 RC without explanation. They didn't, the question is just give, not verify, neither determine, neither, I don't know, prove or anything of the sort. Okay, so I'm thinking of Marianne at this moment. Probably Marianne, when she sees this equation, she won't be able to simplify it. Marianne, please, every time you see an exponential, I don't want you to panic. Just think of it as being any number to a certain power. If I tell you 10 to the power 2, I hate thin pens. If I tell you 10 to the power 2 plus 10 to the power 2, what do you say? It's twice 10 to the power 2, for example. Now replace 10 by exponential. It's exactly the same thing. All right? Try it. Now, concerning the final question, I'm not going to take a lot of time on it because it's a conclusion, with values. What does it say? They want to know the duration of the lightning. So, okay, so you have a lightning, and the lightning is a discharge between the cloud and the ground. It's a total discharge that would empty the charge on the cloud. So how much time do you need to empty all the capacitor? It's like the time of the discharge. That's why they did 5 RC. The duration of the lightning is the time it takes for the cloud to empty itself fully. Determine the maximum current. The maximum current, probably I can help you from here. The maximum current, maximum is whatever you have before the exponential. Let me zoom in and show you in here with a very thin pen. So you see the exponential, what you have behind the exponential is the maximum value. Anyway, according to Ohm's law, isn't current total voltage over total resistance? So yeah, total voltage is the battery, total resistance, you only have 1 R in the circuit. But anyway, all these exponential functions, increasing or decreasing, if you want to know the maximum value, take everything behind the exponential part. okay, in front of the exponential part. I know that this was a very brief discussion of the problem. Please take your time to solve it again, and please get back to me if you have any questions, okay? Thank you.